Hello everyone. In this video, I'm going to show you how to construct Gaussian pyramids and Laplacian pyramids. And as well, I'm going to show you how to put any window that you're going to show an image on in a specific location. So sometimes, for example, for pyramids, you want to put these images in a specific order. So you kind of show that pyramid in a better way, render it better to the user. So for that, I'm going to show you the move window command. So here, I use the two images that you can also find on the OpenCV tutorial, one for an apple, one for an orange. So I got those two images, I read them in, and then the first thing I do, I get the size of these images, which here I resize them to 512 by 512 pixels. And then I put one image here at about 30 and 30, the top left corner of it, and the other image, I move it to here, the top left corner, where it is kind of, the border of it is going to be tangent to the other image. So I add 30 plus the shape 1, which is the number of columns, 512. To the X position, I'm not going to change the Y position. So as I said, one is where this cursor is moving. The other one is going to be here, okay? So these two images are going to be side by side. And I need to create a window with a name. So I use the command cv to name window. I give it a name. And then to that exact name, I apply the move command. I say cv to move window, and then I pass to it the exact X and Y location. And then finally, on that exact same name again, I'm going to show some image. Here, I'm going to show the apple. On the other one, I'm going to show the orange, right? So if I just do this part without anything else, you clearly can see the exact positioning of my images. Look here, right? You see this image is starting at 30, 30. This one is at 30 plus 512 and 30. So the images are, it's like the etch a stack command, right? Remember in NumPy, we have etch a stack, which I'm going to use at the end of this code. That's the same as doing it that way, but instead of showing it all on one window, here I'm showing it on two separate windows. But my positioning is perfectly accurate. If I don't do it this way and I just use simple IMShow commands, then depending on where these windows were last time, that is going to determine their position this time. And it's not going to be perfectly separated like this. They can have overlap. So if I put them like this time, and I run the code next time, and I comment out those lines here, these lines of 13, 14, and then 16, 17, you see that the images are going to appear just like with the overlap I just showed you. So this name window and specifically the move window are very useful command that here I'm going to use them with a little bit more control, so that I kind of shape something like a 2D pyramid. So now, here I want 3 levels of Gaussian pyramid or Laplacian pyramid, or I can have 4 levels or as many levels as I want, right? And then, you know, in a Gaussian pyramid, what you do is you basically will reduce the size of the images in half. And typically that's not just the only thing you do, right? Because you also smoothen out the images and reduce the size in half. And that is to avoid aliasing and other problems that happen at the smaller images, right? Where the frequencies are going up. So are reduced in half and smoothened, right? So that's what you do to get to the Gaussian pyramid. So the commands that you can apply this to are called what? One of them is called pyramid down for going down in size, and then the opposite of that, if you want to go up in the pyramid, so going to the bigger images, right, to the original image, then we have pyramid up. So this pyramid down is basically smoothing up the images and reducing in half of the dimensions, both directions at the same time. So what I'm doing here is I'm saying, hey, I have a list that I started empty. This list has all of the images Gaussian of the Gaussian pyramid of image A, which is apple, And this other list has all of the images of the Gaussian pyramid for image B, which is the orange. I start them as empty lists, and then I go ahead and copy these images into two new images called G1 and G2, right? And the first thing I do, I will append what? To my empty list G1 and G2. So G1 and G2 are now appended, are added from the right end to what? To these two empty lists. Then what do? I reduce the size of them and reduce them in basically the contrast by smoothing. And so I go down the pyramid. Here, down means going down in size, okay? If you consider the pyramid upright, that is going up. But typically, they consider these pyramids upside down. So when you go down, you are reducing in size. So G1 and G2, I'm reducing them and then reapplying them back to G1 and G2. And then what? In the next iteration of the loop, these G1 and G2 that are reduced are going to be appended back to the list, right? So the first element of my empty list are going to be the original images. The next elements are going to be the reduced in half, the next elements reduced in fourth, and so on and so forth, as many as the number of levels I want to go. Now here, to put them exactly where I want, each time I'm updating the position on the screen that I want to put these images, right? For images A and B, the original images, I put them in those two locations that I showed you. But now what do? Each time I divide the size of the image by 2 to the I plus 1. Remember here, I'm starting I at 0 and going to n level minus 1. So remember, it's the range command. So I start at 0 and go to 2 here. So when my I is at 0, this number is going to be 2 to the 1. So I'm dividing the value by 1. So if it's 512, this guy is going to be 256. I add the 256 to what? To the position A, as well as to the position A, X and Y. The same thing for BX and BY. So what does it do? If the top left corner of image A is up here, then the top left image of the next level of the Gaussian pyramid for A is going to come down to kind of what? The middle of the original one. And the next one is going to go down to the middle of the previous one and previous one and previous one. And when you look from the top, it kind of looks like a pyramid, not upright pyramid, probably skewed pyramid, right? A tilted pyramid, but it is going to show the images in much better shape and much better order. So for that, here I add my comments right there. And let's look at the Gaussian for both A and B. So let's take a look. There we go. You see, this perfect arrangement that I made is using those formulas and those relations. So first I start my position here, then I come to here, then I come to here and here and here. And every time these increments in X and Y is basically half of the size of the image that I have at the moment, and that is determined by this value divided by 2 to the power I plus 1, because I is increasing, this number is increasing, but this whole number is decreasing, is reduced in half by size. So I get these two beautiful what? Pyramids, right? This comes here, this goes in the middle of that, this goes in the middle of that, and this goes in the middle of that. And you see I have 3 levels, right? This is level base, which is not really a part of the pyramid. This is level 1, 2, and 3. This, you might call it level 0. And I have the exact same thing for what? For the orange. So you see the very good arrangement, right? And you see the image is getting, the details of the image are being reduced as you go down the pyramid, of course. So this is the Gaussian pyramid, right? Now, what is the Laplacian pyramid? So Laplacian pyramid is the difference of the Gaussian pyramid, basically. And the way that you form a Laplacian pyramid, I'm going to have a video on theoretical part of this. But the Laplacian pyramid at each level is what? Is the difference between the Gaussian pyramid of the image at that level and the expanded. Here by expand we mean resizing it to twice as big in the x and y direction. So expanding means making it bigger, going basically not down the pyramid, going up the pyramid. So resize it to a bigger size, to 2 times bigger, for what? For the image at the level above it. So if I have a small image at the next level, I'm gonna resize it back to the size that is comparable to the Gaussian at this level. Now that these two images are the same size, if I subtract them, the only thing that would be remaining is basically those details that I got away by the smoothing, right? So it's kind of like an image minus the smoothened version of the image. And what is it that you smoothen out? You remove when you smooth. What is it that you remove? The high derivatives, the noise, those small those changes in the light intensities, right, in the colors. So if I subtract the two, I expect to get basically the boundaries, the edges, the noise, right? So your Laplacian pyramid should have the noise, but most probably, most dominantly, it should contain the edges of your image, right? And this is exactly what I'm doing here. If you look, this time I start at what? I start at the very, very what? Smallest image of the Gaussian pyramid. And I said the very smallest image of the Gaussian pyramid, I call it to be my first of the Laplacian pyramid. Then what? Then I go backward from n level minus 1, which is 2 in my case, because n level is 3. I go from 2 backward to 0, or not 0 actually, to 1, with a step of -1. So I'm going backward now. I start at the smallest image, right? Then what? What do? I resize this image to 2 times bigger of itself, subtract it from the image of the previous level, which is already 2 times bigger, and then the difference between them is gonna be what? Is gonna be those edges for that level, and I'm gonna append it to my Laplacian pyramid list for A, and then I do the same thing for Laplacian pyramid for B, which is another list, right? And I start those two lists, as I said, with what? With the Gaussian at the smallest level. For the smallest level, I cannot subtract anything anymore. I mean, I cannot go to the level below that the smallest. There is no level smaller than the smallest. So I have to say that the tip layer of a Gaussian pyramid and the Laplacian pyramid are the same, basically. So this is the Laplacian pyramid. So now I'm going to put my comments here, and I'm going to show you the Laplacian pyramid, which, as I said, should involve edges. So Gaussian, and this is, you see, this is the Laplacian. At the large level, you clearly see the what? The edges, and you clearly see these high derivatives and these noises, those variations. And these are the Laplacian at the lower levels, right? Or upper levels, you might call it, depending on which direction you're looking at it. The smaller versions of them, right? You clearly can see side by side. It mostly involves the small details, the subtle changes, sudden changes, I'm sorry, the sudden changes, and the edges. These are the things that the Laplacian pyramid will grab out of an image for you. Okay, so this is Gaussian pyramid, Laplacian pyramid. Fine. What can you do with these? One of the applications is blending the images together without visible boundaries. So for that, I want to show you something. For example, let's say I want to blend this apple and orange images. I take half of the apple image, I take half of the orange image, and I put them together. Well, what would you get if you don't use any pyramid? What you would get would be something interesting. Let me show you that. So if I do not use any pyramids, right? If I do not use any pyramids, this is what I will get. Let me make sure I copied everything. I guess I did. Let's run it. Seems like I messed up some parts. That the definition of columns here. Columns. I see. That's okay. I can do it. So here I add something for you. That is going to be a dot shape 1. Okay, that should do the trick. Let's see now. Look at that. You see, here I have made half of the apple, stacked it over half of the orange, and you clearly see this big edge, right? That even if I did something very nice, very amazing graphics, here, of course, there is some extra dimension here, but if I did an amazing job, you still say, hey, look at that. That edge is kind of, that clear cut edge is not a good thing to have, right? That is, other than, of course, you cannot have such a fruit, but that is telling me that I haven't done an amazing job blending these two together. I have a visible edge between them. Now, what you can do is to use pyramids to help you get rid of that edge. How would you do that? Here, I create images using my Laplacian pyramids from A and B, where I have images similar to this apple and orange, where half of the image I take from the Laplacian of A, half of the image I take from Laplacian of B at that same level. Okay, so half of Laplacian and of A, half of Laplacian from B, the left side from A, the right side from B. I take them and then what? I stack them together. I put them together just like this image I showed you. Then what I will do is I start at what? At the very smallest level of the blended Laplacian pyramid. I expand it, resize it to 2 times bigger, and then add it to its previous level. And then whatever I get, again, I resize it by a factor of 2, and then add it to the previous level until I get to the very largest size of the blended Laplacian pyramid. When I add all of them together, now this blended pyramid at this bottom, when I did all of those addings and resizings, the thing that I get at the very bottom, that is going to be a blended image where what? Where the visible edge that you had is not going to be there anymore. Okay, so let me show you that. Here, compare this against that. Do you see here the edge is kind of washed out? It's not easy to see the edge here on the left. I mean, of course there is edge, but it's not clear cut like this. It's not perfectly clear cut like this. It's a little bit more blended into each other. Here in this region, because the colors are quite closer, it's harder to see it. In this region, of course, the colors are quite a bit different, so the edge is still visible, but in this area, you can clearly see that the blending is much better here compared to here. And again, I go to the theory behind this in a separate video, but that's one of the applications of Gaussian Laplacian pyramids. The other application is in optical flow calculations, which again, I'm going to have a separate video on theory part of it, and then a separate video on what? on the calculation of it, whether in MATLAB or in OpenCV. So they have their own applications. You can also use them for feature detections, like the SIFT method is using these pyramids and so on. So these Gaussian and Laplacian pyramids, they are used in several methods in computer vision and image processing. So I just wanted to show you how to do it in OpenCV and get you those nice kind of 2D pyramid versions like these using the move window, so you have a better visualization. Thank you so much for your attention. I'll see you in the next lecture.